right, let's finish up 7.8 right now by going to some of these problems that have a little bit more calculation than what we had before here. Sorry, I just got to get my bearings on where we left off from last time. We're just going to start right now on part C. I just wanted to make sure we were in the right place there before we got going. So here we go. Part C was find the partial pressure if Kp was equal to 0.025. Okay, so again, we're going to be solving for an x kind of thing in this same problem, and you remember that the initial pressures were 0.8, 0.2, and then we did the minus x, same thing. We have a different value for the equilibrium constant here, our Kp. So when you set up the Kp, remember parentheses, because it's Kp and it's partial pressures. And when you put the values in there, 2x, and that's going to be squared, so you just plug in the 2x squared. And both of these guys didn't change much last time. However, we have reached a situation where Keq is greater than 1 times 10 to the 4th. It just is not a small enough value for us to guarantee that I can leave those x's out of the mix. So that means on this problem, you get to do some fun math. Okay? Notice we're multiplying these things through here. X times x, they're negative, would give you a plus x squared. And you carry these things through when you get a minus 0.8x and a minus 0.2x. That turns out to be 1x, minus 1x. So that's why that math worked out that way. So 4x squared, and then you've got this thing right here that you got to solve for an x squared and an x and just a regular old number there. So what we did is we moved everything over to the other side here. Okay, so when you do the math on that and you multiply this whole thing, you can see that that 0.25 carries through on both the x and the minus x, and when you take 0.16 times 0.0025, you'll end up with 4 times 10 to the minus 4th. Okay, so now what you want to do is combine the like terms, sneak this guy over to the other side, and notice the way we did this is let's keep that x quantity positive and then flip the other sides there. So essentially what we did is bring them all these things over to that side. If you think of it this way, this number is going to that side, this number going to that side, and then they flipped it again. So a little bit confusing the way they set it up here. The bottom line is if you can come up with, you want 0 to equal your x squared quantity, your x quantity, and your just a simple number portion of that, and that's going to be, of course, your quadratic formula, and you've got an A and a B and a C. See if I can remember the song. X equals negative B plus or minus the square root. Nope, I didn't do it right. B squared minus 4AC all over 2A. Something like that. Seems like I add an extra syllable in there. B squared minus 4 has one syllable. 4AC. I don't know. Maybe somebody can share that song with me and do it right. Bottom line, that's the quadratic formula. So we get to do some fun math, an actual application of the quadratic formula in the real chemistry world. So your B quantity is the portion of the. So we just go back and look at the equation right there and see where you get A, B, and C from. Okay, so and plug those numbers in. And you got to do B squared minus 4. Interestingly enough, that was our value to the negative 4th power. You multiply those things all through. So again, make sure you crunch those numbers. Keep things nice and organized. And of course, since it's plus or minus, you're going to end up with 2 possible answers. And since you're talking about a concentration, I think you're going to have to say that the one that is positive is the correct answer. And you are going to be right. Okay? So you got to take that plus value right there. So that is the X value. It was a little bit more work, a little bit more math, but beware when that K value, when at the very beginning of the problem, if that Kp or Kc is not really, really small, it's going to do this. But what we're going to find out is it was really close to that borderline. So we're not even positive that it's going to affect our final answer. We can do the first part, finding the nitrogen monoxide by just taking partial pressure is 2 times the X value. So multiply that by 2 and just round it to 2 sig figs, and it's that many atmospheres for the partial pressure of nitrogen. Now, the nitrogen is 0.80 minus X. Before that was so small that it didn't change the 0.80. Now, if you'll notice this on your calculator, and you're going to adhere to your rules, this is the least accurate, the 80. So those are you can't have anything past this right decimal point there, 2 places to the right, and this is 4 places to the right. So my answer can have 2 places to the right. And as it turns out, when you punch those numbers in your calculator, you end up with 0.79 atmospheres, very close to the 0.8. But you would have been wrong if you would have made that assumption, and you'd have missed a couple of points on this one, right? So 0.2 minus X, you do that same thing. You can see it chisels off just enough to change it. And when you plug in those numbers again to check it, it'd be close to this, but with all the rounding and sig fig stuff we do, it's not always going to be exact. So that was an application where you had to go the extra step and use the quadratic formula. And right now, that's it. You are done with the lectures, and you can start tackling all the problems for 7.8 right now. Thanks for coming.